Hello, thanks, Johan Cantor. Today, I'm going to talk about pressure. Now, what is pressure? But before I tell you, subscribe to the channel to support us. Like the video if you like the video, dislike the video if you dislike the video, and comment down below in case you want to comment down something that is related to pressure. So, what is pressure? It is essentially force applied on an area. How do you calculate pressure? If you know the force and the area, it would be force divided by area. Now the force will be in N, and area, let's just say meters square, or well, whatever you want. Actually, meters, centimeters, kilometers. So kilometers is a little bit too big usually, because why is there like a block a kilometer wide? If that would be acceptable. However, we'll just use meters or sometimes centimeters. Actually, most of the time centimeters. Solve each of the following problems. The weight of a 200 Newton printer is spread over 0.5 meters square. This is the pressure it exerts. So it is 200 N divided by 0.5 meters. Just copy. Oh, I did not realize that exists. Equals to 200 divided by 2. Oh, wait, no. 200 divided by 0.5. Well, we can transform it into a fraction. 200 over 1 multiplied by, we just put brackets. So, yeah, brackets. Okay. Multiplied by 1 over 2, which makes 0.5. That will be 1. Erase that and divide this by 2 equals to 100. Divided by 1 times by 1 equals to 100. Wait a second. I think we need to reverse it actually. It equals to 2 over 1, which means multiply. Wait a second. No. Division equals to multiplication. So 0.5 equals to 2 over 1. 200 n times by 2 over 1 equals to 200 n times by 2. It equals to 400 n. We forgot the meter square. Yeah, we forgot the meter square. Okay, put there and then there. Let's just get rid of that so it does not cause any confusion. Then 400 n divided by m square. I mean, it does work. Wait, let me just calculate. Or we could just make it into centimeters, which would make it 500 centimeters. I just realized how absurd the numbers are. It should not be 500 instead. It should be 50. 1 meter equals to 100 centimeters. So it's nice. It's 50 centimeters equals to 200 divided by 50 centimeters square. Well, okay, then 4. Okay, move the back zeros, and then yeah, we got 4. We have 4. So the first one was wrong. Nice. Hey, now on the page. So, alright, so it's still multiplication. That one, so yeah, this works. This is actually just simplification this part, because you 200 divided by 5, 200 divided by 5, and then you just mix together the symbols. And if you think about it like a fraction, means that that will be simplification. And why is that? What's this? What's that? So subscript. Nice. Just load line of text. Okay. So yeah, and also mind you, pressure is everywhere. I'm typing. Yes, that there's pressure because I pressed down on the keyboard. You watching? You watching this? You touch the screen to pause. Pressure. Pressure on the screen. Then you're sitting on the couch. Pressure on the couch. The couch on the house. I mean the floor. Not really on the house. Unless your house is literally made with the floor. Usually it's just a floor is just a component. But if your house is a floor, oh, not that kind of floor, not the levels. Let's say levels of a building. Oh, yeah. No. What I meant is a literal floor. Ouch, on the floor, pressure. The floor on the soil, pressure. The soil on iron, pressure. Of just the soil on the stone, pressure. The tree on the soil, pressure. That's a lot. The gravitational attraction that is constantly forcing, let's say, forcing the earth to be well round, pressure. And then the sun. Okay, I explained in the last video that the gravity is constantly trying to form the sun into the smallest shape possible. Pressure. So yeah, that's essentially the computer on your desk, pressure. And then the bird on the perch, pressure. And then that's, I know that's a lot, quite a lot. Then there is atmospheric pressure, decreases every time you went up because air has weight and it's pushing down on you. So yeah, that's pressure too. You standing, pressure. You sitting, pressure. You lying down, pressure. You sleeping, pressure. The printer on the desk, pressure. Lamps, pressure. Lamps on the floor, not on nothing. How can it be not on nothing? Even if it is in space, there is at least, let's just say, not, but there is some hydrogen at least in space. There's a little bit, very little. It's not a perfect vacuum. The TV on the wall, let's just say pressure, especially on the bolts securing the TV to the wall. yeah, supports the weight by putting the pressure on the wall towards force, and it can come out. Why? Like, your screws, yeah, they are designed so that they can only be twisted and not just straight out fall. It will be disastrous if it's just a bug. So yeah. Oh, and by the way, why is it still in superscript? The more surface area you have equals to less pressure per meter or centimeter, kilometer or millimeter. Yep. I think it will be best to put this in object. Yeah, I think it will be best to put this in object. Why, you might ask? Because there is more surface area to dissipate the pressure into. Snowshoes, when you normally sink in snow, well, you cannot sink in snow with snowshoes that is, well, big enough for your size. I am not directing this to someone because, people have different body weights. So yeah, I suppose that is it. Thank you for watching and goodbye.